Tools in science. One way to collect data is to take measurements. To get the most accurate measurements, you must use the proper tools to gather data. For example, you can use a meter stick to measure length. You can use a thermometer to observe changes in temperature. Two other tools and their uses are shown in Figure 1. After you collect data, you need to evaluate and analyze the data. Calculators are handy tools to help you do calculations quickly. Or you might show your data in a graph or a figure. A computer that has the correct software can help you display your data. A pencil and graph paper are also tools you can use to display your data. Making measurements. Many years ago, different countries used different systems of measurement. In England, the standard for an inch used to be 3 grains of barley placed end to end. Other units were originally based on parts of the body, such as the foot. The International System of Units. In the late 1700s, the French Academy of Sciences set out to make a simple and reliable measurement system. Over the next 200 years, the metric system was formed. This system is now the International System of Units, or SI. Because all SI units are expressed in multiples of 10, changing from one unit to another is easy. Prefixes are used to express SI units that are larger or smaller than basic units, such as a meter and a gram. For example, kilo means 1,000 times, and milli indicates 1/1000th times. Table 1 shows common SI units. Length. To describe the length of a large classroom, a scientist would use meters. A meter is the basic SI unit of length. Other SI units of length are larger or smaller than the meter by multiples of 10. For example, if you divide 1 meter into 1,000 parts, each part equals 1 millimeter. So, 1 millimeter is 1,000th of a meter. Mass. Mass is the amount of matter in an object. The kilogram is the basic SI unit for mass. The kilogram is used to describe the mass of large objects, such as a suitcase. 1 kilogram equals 1,000 grams. So, the gram is more often used to describe the mass of small objects. Masses of very large objects, such as cars or airplanes, are often expressed in metric tons. A metric ton equals 1,000 kilograms. Volume. Imagine that you need to move some lenses to a laser laboratory. How many lenses will fit into a crate? The answer depends on the volume of the crate and the volume of each lens. Volume is the amount of space that something occupies. Liquid volume is expressed in liters. Liters are based on the meter. A cubic meter is equal to 1,000 liters. So, 1,000 liters will fit perfectly into a box that is 1 meter on each side. A milliliter will fit perfectly into a box that is 1 centimeter on each side. So, 1 milliliter equals 1 cubic centimeter. Graduated cylinders are used to measure the volume of liquids. The volume of solid objects is usually expressed in cubic meters. The volume of smaller objects can be expressed in cubic centimeters. To find the volume of a crate or any other rectangular shape, multiply the length by the width by the height. Density. If you measure the mass and the volume of an object, you have the information you need to find the density of the object. Density is the amount of matter in a given volume. You cannot measure density directly. But after you measure the mass and the volume, you can calculate density by dividing the mass by the volume, as shown in the following equation. D equals m over v. Temperature. The temperature of a substance is a measurement of how hot or cold the substance is. Degrees Fahrenheit and degrees Celsius are used to describe temperature. However, the Kelvin, the SI unit for temperature, is also used. Notice that the degree sign is not used with the Kelvin scale. The thermometer in Figure 2 shows how the Celsius and Fahrenheit scale. Models in science. A model is a representation of an object or system. A model uses something familiar to help you understand something that is not familiar. For example, models of individual systems in the human body, such as the nervous system, can help you understand how the body works. Models can also be used to explain the past or to predict future events. There are three common kinds of scientific models. They are physical, conceptual, and mathematical models. However, models have limitations because they are never exactly like the real thing. Physical models. Model airplanes, dolls, and drawings are examples of physical models. Other kinds of physical models can help you understand certain concepts. For example, look at the model space shuttle and the real space shuttle in Figure 3. Launching a model like the one on the right can help you understand how a real space shuttle blasts off into space. Conceptual models. The second kind of model is a conceptual model. A conceptual model tries to put many ideas together to explain or summarize something. After a conceptual model is formed, data are sometimes found that do not fit the model. The model may then be revised to fit the new data. For example, the Big Bang Theory is a conceptual model that explains why the universe seems to be expanding. This model is described in Figure 4. Although the Big Bang Theory is widely accepted by astronomers, some data do not fit the model. So, conceptual models may not take certain data into account, or the models may include certain ideas, but not others. Mathematical models. Every day, people try to predict the weather. One way to predict the weather is to use mathematical models. A mathematical model is made up of mathematical equations and data. Some mathematical models are simple. These models allow you to calculate things such as force and acceleration. But other mathematical models, like those that predict the weather, are so complex that only computers can handle them. Some of these very complex models have many variables. Using the wrong value for even a single variable could cause the model to make highly inaccurate predictions. Models, the right size. Models are often used to represent things that are very small or very large. The solar system is too large to view all at once. So, a model can help you picture the thing in your mind. Sometimes, models are used to learn about things you cannot see, such as sound waves. Look at Figure 5. A coiled spring toy is often used as a model of sound waves because the spring toy behaves similarly to the way sound waves do. The limits of models. Models are an important tool for scientists. Mathematical models can help scientists analyze complex systems quickly and efficiently. For example, scientists can use models to study how certain drugs might fight diseases without scientists having to test the drugs on animals or people. But it is important for a scientist to remember the limitations of the models that he or she uses. A model is not exactly the same as the real object or system. To make sense of the information gathered, a scientist must know the ways in which a model does not act exactly as the real thing does. Using models for scientific progress. Models can represent scientific ideas and objects. Models can also be tools to help you summarize and learn new information. When scientists need to communicate information that would be difficult to explain, they often create a model. Figure 6 shows a model of a protein molecule. Molecules are too small to be seen with your eyes, and some molecules are made of a large number of atoms. So, a drawing of a molecule that tries to show the location of every single atom would be very confusing to look at. But by using a model, you can see the shape of the molecule from any side. Scientific theories. Models are often used to help illustrate and explain scientific theories. In science, A theory is an explanation for many hypotheses and observations. Usually, these hypotheses have been supported by repeated tests. A theory not only explains an observation you've made, but also can predict what might happen in the future. Scientists use models to help guide their search for new information. This information can help support a theory or can show that the theory is wrong. Keep in mind that models can be changed or replaced. These changes happen when scientists make new observations. Because of these new observations, scientists may have to change their theories. Figure 7 compares an old model with a current model. Scientific laws. What happens when a model correctly predicts the results of many different experiments? A scientific law can be constructed. In science, a law is a summary of many experimental results and observations. A law tells you how things work. Laws are not the same as theories. Laws tell you only what happens, not why it happens. Look at Figure 8. A chemical change took place when the flask was turned over. A light blue solid and a dark blue solution formed. Notice that the mass did not change, which demonstrates the law of conservation of mass. This law says that during a chemical change, the total mass of the materials formed is the same as the total mass of the starting materials. However, the law doesn't explain why. It tells you only what will happen during every